Welcome to Veenaasri Tuitions. Oscillations, long answer 8 marks. Show that the motion of a simple pendulum is simple harmonic and hence derive an equation for its time period. What is seconds pendulum? What is seconds pendulum? Once again, listen the question. Show that the motion of a simple pendulum is simple harmonic. సింపుల్ పెండులం యొక్క మోషన్ సింపుల్ హార్మోనిక్ అని ప్రూవ్ చేయాలి. అలాగే టైం పీరియడ్ ఈక్వేషన్ మనము ఫైండ్ అవుట్ చేయాలి. సెకండ్స్ పెండులం అంటే ఏమిటో డెఫినేషన్ రాయాలి. సో రైట్ డెఫినేషన్ ఫర్ సెకండ్స్ పెండులం. సింపుల్ పెండులం ఈజ్ సింపుల్ హార్మోనిక్. టు ప్రూవ్ సింపుల్ పెండులం ఈజ్ సింపుల్ హార్మోనిక్, derive an equation for its time period. So ఇందులో ఎన్ని ఉన్నాయి క్వశ్చన్స్? A, B, C. 3 questions are there. So it is A, it is B, so it is C question. Answer A. To show that motion of simple pendulum is simple harmonic. సింపుల్ పెండులం మోషన్ సింపుల్ హార్మోనిక్ అని ప్రూవ్ చేయాలి. సో ఇన్ దిస్ ఫస్ట్ పాయింట్, కన్సిడర్ a simple pendulum of length small l, mass small m, suspend from a rigid support O as shown in figure. So it is a rigid support. You take a thread of length L, bob of mass small m. So you take length from the center of the bob small l. So you pull one side. So the displacement x and the weight acts always downwards, small m into g. So length of string is L, small l, mass of the bob small m, rigid support O. ఒక థ్రెడ్ తీసుకుని దానికి ఒక వైపు బాబ్ను కట్టాలి, అనదర్ ఇంకొక ఎండును ఇక్కడ సపోర్ట్కు ఫిక్స్ చేసినట్లయితే దాని యొక్క మాస్, బాబ్ యొక్క మాస్ ఏమవుతుంది, లెంత్ ఆఫ్ ద స్ట్రింగ్ సెంటర్ ఆఫ్ ద బాబ్ నుండి స్మాల్ ఎల్ అనేది తీసుకోవాలి. లెట్ ద బాబ్ మేక్స్ అన్ యాంగిల్ టీటా with the vertical. So it is a vertical, so some angle you are taking, the angle is theta. So write that let the bob makes an angle theta with the vertical at an instant. See here, instant means we are pulling aside, so the bob makes an angle theta with the vertical. Clear? ఒకవైపు మనం పుల్ చేసినప్పుడు మాత్రమే ఇక్కడ యాంగిల్ అనేది టీటా అవుతుంది. మీన్ పొజిషన్లో ఎంత ఉంటుంది, యాంగిల్ 0 ఉంటుంది, టీటా అనేటువంటిది ఉండదు. నెక్స్ట్ పాయింట్, సెకండ్ పాయింట్, ద వెయిట్ mg resolved into two perpendicular components. See, it is mg, so perpendicular means, so these two are perpendicular like this, both are perpendicular to each other. One component is mg cos theta balances the tension capital T. See here, it is mg cos theta, this direction, so in opposite direction tension capital T, balancing mg cos theta this direction, so tension is in opposite direction, balancing. The other component, next point, the other component mg sin theta provides restoring force capital F. See here, we are pulling aside, it is capital F, so the bob goes towards mean position, bob అనేటువంటి mean position వైపు వెళ్తుంది, so it is mg sin theta, both are in opposite direction but equal. Third point, restoring force is given by capital F is equal to minus mg sin theta, but we know that F is equal to ma according to Newton's second law. Now So here f is equal to minus mg sin theta, here also f is equal to capital F is equal to ma. Both are equal, so you write both left and right side ma is equal to minus mg sin theta. Left side and right side cancel, a is equal to minus g sin theta. Next step, a is equal to minus g into theta. Take it as first equation, write within bracket since when theta is very small, sin theta becomes theta, means sin theta is equal to theta avutundi. So see the mg down vertical downward direction, so pull aside, it is mg cos theta. So the length is L, so displacement moved by the bob small x L. So theta makes an angle between vertical and string of the length L. Theta is equal to opposite by hypotenuse x by L. Take it as second equation, it is fourth point. From first and second equations we get a is equal to, so here first and second equations, a is equal to nothing but, so you observe here instead of theta you substitute x by L, minus g of x by L. Next you observe here g and L are constant. G means acceleration due to gravity and length of the string are also not changing. Therefore minus g of within the bracket g by L into x. So we write in bracket g by L is equals to constant. Therefore a is directly proportional to minus x. Hence proved that the motion of the simple pendulum is SHM, simple harmonic motion. B bit derivation for time period, capital T. Sixth point continuation, if omega is the angular velocity, of the bob, then its acceleration is the acceleration formula. Acceleration is a equals to minus omega square x. You take it as fourth equation. We got already a is equal to minus g by L into x. So from third and fourth equations we get, so third equation is, I am writing a is equal to minus g by L into x. Fourth equation, a is equal to minus omega square x. So it is third, it is fourth. So AA is both are equal, means right, minus omega square x is equals to minus g by L into x. So minus minus get cancel, x left and right side cancel, remaining omega square is equal to g by L. Apply square root on both sides. Omega square under root of is equals to g by L under root of. So here square and root get cancelled. Omega is equals to under root of g by L. Angular velocity is equal to under root of g by L is the angular velocity formula. But we want derivation for its time period. Time period t. T is equal to 2 pi by omega. It is the formula for time period. T is equal to 2 pi by omega. I am substituting omega value g by L under root of 2 pi by 1. So it goes to numerator, total reverse, means g by L becomes L by g under root of. So 2 pi under root of L by g is the equation for time period. Clear? Next, 8th point. T is equal to 2 pi under root of L by g is the equation for time period. Next, seconds pendulum. Definition. You write seconds pendulum. A pendulum with a time period 2 seconds is called seconds pendulum. Listen and write a pendulum with a time period 2 seconds is called seconds pendulum. ఒక పెండులం యొక్క టైం పీరియడ్ 2 సెకండ్స్ ఉంటే దాన్ని మనం సెకండ్స్ పెండులం అని చెప్పవచ్చు. సో యూ ప్రాక్టీస్ మెనీ టైమ్స్ యూ విల్ బికమ్ పర్ఫెక్ట్. ప్లీజ్ ప్రాక్టీస్ more and more times. Thank you.